Hello Year 11 and welcome here to our 8th video for our unit on measurement. We're looking at volume and surface area of a prism today. Now first of all we're going to talk about volume and units of volume. Right, these are cubic units, cubic centimeters, cubic meters are the two that we're going to use the most. Now to do volume conversions we do the linear conversion 3 times. So for example, to convert centimeters to meters, we would normally divide by 100. To convert square centimeters to square meters, remember we do that twice. So I divide by 100 and then by 100 again. To convert to cubic centimeters, from cubic centimeters to cubic meters, we're going to divide by 100 3 times because it's been cubed. Okay, so here's this first example here. It asks us to convert 567,750 cubic centimeters to cubic meters, right? And all I'm going to do here is move the decimal place, right? 2 spots for 100, 2 spots again, and my third time, right? This is equal to 0.567750, or just 75 cubic meters. So that's the meters with the little cube there. So what this really means is there are 1 million cubic centimeters in 1 cubic meter, but do the linear conversion 3 times I find to be the easy way to remember. Okay, now we're going to talk a little bit about a prism. A prism is a solid, right, that sort of has a consistent cross section, right? Essentially it's got the same shape on the top and the bottom, right, or the front and the back. Same shape all the way along, same shape and size. Now the amount of space it occupies is its volume. The amount of space within it is called the capacity. Now there's not a lot of difference between volume and capacity. We use different units for capacity. Typically we will talk about litres. Right? Now 1 litre is equivalent to a cube that's 10 centimeters on each side. 1,000th of a litre is a milliliter or a mil, and that's equal to 1 cubic centimeter. So to convert cubic centimeters to milliliters, it's just a straight 1-to-1 conversion. So that's nice and easy. 1 cubic centimeter equals 1 milliliter. 1,000 milliliters is 1 liter. 1,000 liters is a kiloliter, and 1 kiloliter is equivalent to 1 cubic meter. So some more conversions to do here. 46 litres to cubic centimetres. So I'm going to say 46 litres equals 46,000 millilitres equals 46,000 cubic centimetres. Okay. Now cubic centimetres to litres, right? That's equal to, so 10,400 cubic centimetres is equal to 10,400 milliliters equals 10.4 liters. Okay, and another one over here, right here. Cubic meters to, now the big M is for megaliters. That's millions of liters. So I can say 3,500 cubic meters is equal to, right, 3,500 kiloliters, right, which is thousands of liters. There are 1,000 kiloliters in a megaliter, so that's equal to 3.5 megaliters. Rightio, unit conversions for volume and capacity. Now we're going to move on to our prism. The volume of a prism is equal to the area times the height. So here we have a trapezoidal prism. You can see that there is, right, if I point over here, a trapezium here and a trapezium here, and that sort of hidden back surface, and they're the same, right? They're joined together by flat surfaces. We want to find the volume of this prism, and to do that I'm going to find the area of this trapezium here, I suppose, which is the same as the trapezium at the front. It's just, I suspect, a little neater if I shade in that back one. I'm going to work out that area there and then multiply it by the height, which in this case is not 6. It's the 15. It's how far apart those faces are. So I'm going to begin by saying the area of my trapezium is equal to, now I prefer to do the average of the parallel sides, that's 8 plus 13 over 2, right? And I multiply that by the distance between them, which is 6. Now, 8 plus 13 is 21. 21 divided by 2 is 10.5. 10.5 sixes, I think, are 63 square centimetres. Now, it's square centimetres at the moment because we're talking about the area. Now, we need to work out the volume, and the volume is equal to the area times the height. So in this case, my volume is equal to 63 times 15. Now, I encourage you to not do any calculations without writing that calculation down first. Now, 63 lots 15, I'm not real keen on doing in my head. It might be 945, but we better check. Oops. Delete, delete. It is 945. Okay, so we'll write that in. Oops. That's not going to work. Now, here, we'll write that in. Now, this time it's 945. Oh, that's a bit weird. 945 cubic centimetres now, because we have calculated the volume. There we go, the volume of that trapezoidal prism. Surface area. This can be quite time-consuming sometimes, surface area, though there are some shortcuts for prisms. Surface area is the sum of the area of all of the faces of this solid. So, my trapezoidal prism back here, you'll see, has 6 faces, right? 2 trapezia and 4 rectangles. Right, and my 4 rectangles there might all be different. On this, right, for this triangular prism here, okay, I have 5 faces, a triangle at the front and the back, and 3 rectangles around the middle. There is a slight inconsistency with this diagram. There's something that we can't be entirely sure about, and we need to work something out. It's often the case with these questions. We have incomplete dimensions. Now, I know that's a 6 there, and I know that it's 4 up to here to be the height. Now, it's a 4. That's all well and good for working out the area of that triangle, but I need to work out the length of this slopey side here to work out the area of that rectangle. I'm going to assume, and of course that's always a way to make a mistake, but this diagram is slightly imperfect. I'm going to assume that this is an isosceles triangle, that these 2 sides have an equal length, because the length of those sides is important. So I'm going to redraw this a little bit more. Just half of that triangle. Okay, now if that's 4, and I said it's isosceles, and that's 3, then by using Pythagoras' theorem, and if I write x here, I could say that x squared equals 4 squared plus 3 squared. Therefore, x equals 5. I'm taking a shortcut there because that is the most familiar of all our Pythagorean triads. So x equals 5, and you know what? I'm even going to write that on here. I'm going to say that's a 5 there, and over here as well. There's a 5 there. Okay, not a bad idea, once you've worked something out, to draw it on your diagram. Okay, we've done the working to do that. Now my surface area is made up of 5 faces, but 2 of them are the same. So I'm going to say the area, and I can use a subscript here. I'm going to say of a triangle is equal to half times the base times the height. That's half times 6 times 4, not 5, that's 4. Equals half times 6 times 4 equals 12 square centimeters. Now, my surface area, so my surface area equals 2 lots of that, 2 lots of my 12, plus I have 2 lots of 5 by 10. Okay, so this rectangle here on the side, that's 5 wide and 10 deep, and there's 2 of those, right? One here, and then there is the rectangle underneath there, which is 6 by 10. Okay, so plus a 6 by 10. Just going to scroll up a little, and we'll say that for my surface area equals 24 plus 100 plus 60, okay, equals 184 square centimeters. Okay, we're dealing with a solid, but we're working out the surface area, so my answer is in square units, and it's 184 square centimeters. So that's surface area and volume of a prism. Remember, for volume conversions, use the linear conversion 3 times. That 1 milliliter equals 1 cubic centimeter. That 1 kiloliter equals 1,000 liters, which is also equal to 1 cubic meter. That the volume of a prism is the area times the height, and the surface area is the sum of the area of each of the faces. Okay, if you've got any questions, you know what to do. Ask me in class. See you then.